finding acute angles. So let's say we have a right triangle and we know the measurements of a couple of the sides, and we're trying to figure out the measurement of an angle. How could we do that? Well, the only easy situation would be the situation where we recognize we have a special triangle, and that's the situation in this picture. When I see a 1 as a leg and a 2 as a hypotenuse, I'm supposed to recognize, wait a minute, I know this triangle. This is the old 1 square root of 3, 2 triangle, which we know is the 30, 60, 90 triangle. Theta, the angle we're trying to find, is opposite the root 3, and so I know then that theta must be 60 degrees. Okay, but what about this second example? Here I have a triangle. I've got a 1 here, a 3 here. There is no special triangle that I know of. How can I find this angle alpha? Well, this is where trig comes in. Is there a trig function I know of that links up the 3 pieces shown in this triangle? Let's see, this would be the hypotenuse. 1 would be the adjacent side to angle alpha. Well, which of the big 3 trig functions links up this angle, the adjacent side, and the hypotenuse? It would be the cosine function. So CAH, C-A-H, cosine is adjacent over hypotenuse. So I can write cosine alpha, cosine of angle alpha, equals the ratio of the adjacent to the hypotenuse, 1/3. The cosine ratio of that angle is 1/3. Now the question is, if I know the cosine ratio, how can I use that then to help me find the angle? Well, I need a new tool, and that tool is called an inverse trig function. I need a function that does the reverse of what the regular trig functions do. And the regular trig functions, you stick in an angle and you get out a ratio. I need a function where you stick in a ratio and you get out the angle. We write an inverse trig function using the name of the regular trig function and then a little -1 here up at the top. This is called the inverse cosine function. It takes in ratios and it spits out angles. So going back to my problem, if I want to know this angle, alpha, I would need to go to the inverse trig function, put in that 1/3, and whatever comes out, that's my angle. You can read this alpha equals cosine inverse of 1/3, or something helpful I learned once, you can read this alpha is the angle whose cosine is 1/3. The angle whose cosine is a nice way to read the inverse function. There's a lot more to say later about the inverse trig functions, but when you're working with acute angles, it's pretty simple. In order to work this out, let's go to the calculator. Let's see, I'm in degree mode. I think that's fine. You've probably noticed that above the sine, cosine, and tangent buttons are the little sign with the -1, sine inverse, cosine inverse, and tangent inverse. To access them, just hit the blue button. I want to choose the cosine inverse function. Inside, I'll put the 1/3, and that's it. Hit enter, and there's my answer. To a couple of decimal places, 70.53 degrees. So alpha is a little more than 70 degrees. Let's look at another example. This one says, given a right triangle, if beta equals 34 degrees and b equals 8.1, find A. Before we start, just a word about labeling in these problems. There is a standard labeling practice. In a right triangle, we always call the 2 legs A and B and the hypotenuse C. Of course, the angle opposite C is the right angle. For the other 2 angles, the angle opposite side A is either called capital A or angle alpha. The angle opposite side little b is often called capital B or angle beta. You'll see both of those things. That's important to know because when you go back to the problem, they're just giving me pieces. It's up to me to fill in the pieces in the right place. They have given me an angle. I always try to draw my picture at least reasonably accurate, so I drew one that looked like it had about a 34-degree angle right here. So that's angle beta. Then they told me side B is 8.1. I now have no choice where to put that in my picture. It's not the hypotenuse. I know it's one of the legs. It has to be the one opposite angle beta. Side B is always opposite angle beta. I want to find A. Well, I know that's not the hypotenuse. The hypotenuse is C. That means A must be here. Drawing a good picture in these problems is so helpful. So how do I find A? It's all about linking up the pieces in your picture. I have this angle. I have the opposite leg. And I'm interested in the adjacent leg. Which trig function am I going to use? Well, SOHCAHTOA, TOA, opposite over adjacent. So I would write tangent 34 degrees is equal to opposite 8.1 over adjacent, which is A. I want to solve this little equation that I've written for A, and if I do, I can figure out the measurement. Let's see, it looks like I need to clear the fraction, so I'll multiply both sides by A. Then I have A times tangent 34 degrees equals 8.1. Remember, tangent 34 degrees is some ratio that will eventually get off the calculator. I don't want to do that yet. You never want to round in the middle in these problems. I'll divide both sides by that number, tangent 34 degrees, and now I have solved for A. All that's left is to type this into the calculator. Again, I'm in degree mode, which is where I want to be. 8.1 divided by tangent 34. The calculator understands that to be in degrees. And here's my measurement. Right about 12 is the answer. 12.01, I guess, rounded to two places. Notice I didn't use an inverse trig function this time because I wasn't looking for an angle. I already had the angle. So again, A is about 12.01. One last follow-up question. What if I wanted to find side C now? Well, I do have the other two sides. It is a right triangle. I could use the Pythagorean theorem. The problem, though, is if you use rounded numbers, then your answer will be slightly off. A here is a rounded number. What would be better then would be to use the exact numbers in the problem, this angle, the 8.1, and then write another trig relationship that links these three pieces. Do you see that it would be the sine function? Because the sine of this angle would be the opposite over the hypotenuse. Always try to use exact values when you can. Thanks for watching.